Okay, accidentally stopped that video watching a exciting calculus online presentation there. Okay, so let's take this up where we left off. Now it says there is an antenna on the top of the building, so here's my craftily drawn antenna from a location 300 feet from the base of the building, and so, you know, this is one of those things we would want to talk about in class, but technically the antenna would have to be over here on the very edge, or we would have to change it so that our 300 feet is, you know, directly below the antenna, but we won't quibble over those little details. From a location 300 feet from the base of the building, the angle of elevation to the top of the building is measured to be 40 degrees, so that's that right there. From the same location, if we go all the way up to the antenna, then we get the angle to be 43 degrees. And so our task is to find the height of the antenna, which is this little piece right here, okay? Alright, so my strategy is going to be just to do this twice with this big triangle here, and first I'm going to find this distance, and then I'm going to find this entire distance, and then if I subtract those two things, what I'm left with will be the height of the building. Alright, so let's start with x. Again, I'm going to use tangent, which is pretty commonly what you use in the air quotes real world, because usually you know the two legs of the right triangle. It's pretty hard to measure the hypotenuse. So I'm going to say the tangent of 40 degrees is equal to the opposite side, which is x, divided by 300, which means that x is equal to 300 tangent of 40. Man, I wish I had a good calculator on here. Didn't I find one the other day? I feel like it didn't have any tangent stuff. It was like the most basic. Yeah, that's worthless. Okay, so 300 tangent of 40 degrees. Do that on my phone. 300 tangent of 40 degrees. So the height of that whole building, sorry, the height of the building works out to be 251.7 feet. Okay, now I'm going to find this total height, so I guess I shouldn't have labeled that y right there. What y is going to be is this whole thing. Really, we're going all the way up and all the way down. Okay. Alright. So that means that this time the tangent of 43 degrees is equal to y divided by 300. So since our angle is a little bit larger, the distance is going to be a little bit larger. So we could have really done this in just one step and just subtracted the two things, but oh well, live and learn. So that works out to be 279.8 feet. And then if you subtract those two things, the height of the antenna, CTIGHT, is going to equal y minus x, which is going to equal 279.8 minus 251.7, which is equal to 28.1 feet. I've got 28 feet probably when it's all said and done. Okay, not so bad. Okay, back to some boring triangles. This is what we have been doing, just sort of in diagram form without words to confuse you. So we're trying to find this whole length here, so what I'm going to have to do is I'm going to have to find this piece right here, which I will call A, and then I'm going to have to find this piece right here, which I'm going to call B, and then I'll add those together, and that'll give me the total length. So if I know this side, that is opposite this. If I'm looking for this, then that is adjacent to that. So once again, it is tangent's world. We're all just living in it. So the tangent of 63 degrees is equal to the opposite side, 82, divided by a. So notice that in this case we're back in the situation where we're dividing by the variable. So that means to solve for that variable we have to switch these around and not go 82 times tangent, but go 82 divided by tangent of 63 degrees. That is something that bamboozles students quite frequently. So if that's something that you're having a hard time picking up on, don't sweat it. Just try to learn to recognize when are we going to multiply and when are we going to divide. And that comes out to be 41.78. Now I'm going to do the same thing with the 39 degrees. So the tangent of 39 degrees is equal to, again, 82, this time divided by b. So again, since my variable is on the bottom, the denominator, I'm going to switch the tangent and the variable and solve. So this is going to be 82 divided by the tangent of 39. And that is equal to 101.26. So, the distance that I'm looking for, x, is equal to a plus b, which is equal to 41.78 plus 101.26, which is equal to 143.04. Okay. Alright, let's do another one of those. So this time I'm trying to find this part here, so this is more like the antenna problem. What I'm going to do is I'm going to find this piece, and then I'm going to find this entire piece, where by that I mean all the way from here to here, and then I'm going to subtract those to figure out what x is. Alright. Okay, so let's find a first. We're going to use tangent again because we have the opposite and the adjacent. So tangent of 56 is equal to the opposite side, 115 divided by a. Oh, before I do it, think to yourself, am I going to multiply by 115 or divide by tangent? Survey says, since the a is on the bottom, I'm going to go 115 divided by the tangent of 56. Not times the tangent of 156, and that is equal to, I think when we get back to regular, I might just sit at my desk and teach. Typing these stuff in, it's way easier for you guys to read than my handwriting. What I need is one of those little virtual keyboards so I can be up in front of y'all and still do it. Anyway, that works out to be 77.57. That's supposed to be a decimal. So much for my idea of sitting and teaching. Okay, now we're going to do this whole big triangle right here. So once again, the tangent of 35 degrees is equal to the opposite side, 115 divided by b. So since we're dividing by the variable, I have to divide by the tangent again. This time it's 35 degrees instead of 56 degrees, so that's going to make the length considerably longer. So b is equal to 115 divided by tangent of 35, which is 164.24. Okay. So then to find out what x is, I have to take b, subtract from that a, so I have to go 164.24 minus 77.57, which equals 64.24 minus 77.57 is equal to 86.67. Okay. Alright, not so bad. until we get to the very last one, which is a UW problem. So you know that's going to be trouble. So this one says the plane is flying 2,000 feet above sea level, so this length is 2,000, towards a mountain. Pilot observes the top of the mountain to be 18 degrees above the horizontal, so he puts his plane on a bearing 20 degrees so he can clear the mountain. Good thinking. The airspeed of the plane is 100 miles an hour. After 5 minutes, the plane is directly above the mountain. How high is the plane above the mountain when it passes directly over it, and what is the entire height of the mountain? All right, this is going to be fun. So the first thing we know is that if the plane is going 100 miles an hour for 5 minutes, I'm going to say that 5 minutes is equal to 1/12 of an hour. So that means the plane will have flown in that 1/12 of an hour if it's going 100 miles an hour. It will go 1/12 of 100 miles. And so that means that the plane has traveled 100 divided by 12, which is 8.33 miles. Is that miles? Yeah, okay. All of our other measurements are in feet, so I need to change that into feet by multiplying by 5,280. So times 5280 means that the plane has actually gone a distance of 44,000 feet. Okay, so that means I can write into here, let me change my font size so it'll fit, that this distance is 44,000 feet. Okay, alright. Okay, if you need this again, you can go back and grab it. I'm going to use that as workspace, so I'm going to delete that. Okay, so now what I'm going to do, since I know that this is 44,000 feet, and I know that this angle, the whole thing, is 20, is I'm going to use this big triangle to figure out what the distance between T and L is. Okay, so let's get some good font going again. So I know the 20 degrees, I'm trying to find the opposite. This time I know the hypotenuse. So opposite and hypotenuse is the sine. So sine of 20 bears is equal to the opposite side, which is TL, divided by 44,000. Okay, take a minute, think on your own. Is he going to multiply by 44,000 or is he going to divide? Well, the answer is that to figure out what the distance TL is, I need to multiply by 44,000 because the 44,000 was on the bottom of the fraction. So I have to multiply both sides by 44,000 to get rid of it. Okay, so that distance TL is equal to 44, not 47, 44, 1, 2, 3, 4,000 times the sine of 20 degrees. So I'm going to go 15,049. Let's just round that to the nearest whole number. Okay, so that is the entire distance right here. Oh, this is a little trickier than I thought. Because I don't, oh, okay, so now what I'm going to have to do is, well, let me write that in there so I can clear up some space for some more work. So this is 15,049 feet. Okay, and that is the entire distance from T to L. All right. Okay, so let's get rid of this work that we did. All right, now I'm going to figure out this whole distance right there because I need that to figure out this side of this lower triangle. So back to the drawing board. This time I know the opposite side, and I'm trying to find the adjacent, so that's going to be our BFF tangent. So tangent of 20 degrees is equal to opposite 15,049 divided by adjacent, which it looks like from the diagram is PL. Okay, so question is again, to figure out the distance PL, do I multiply by 15,049 or do I divide by tangent of 20? And the answer is that since the PL, the variable, is on the bottom, that means I have to take 15,049 and divide it by tangent of 20. And so if I do that, I get, let's see, divided by tangent of 20. Not sure if I'm doing that right on my calculator. Does that make sense? Yeah, 41,346 feet. 41,346 feet. Okay, so that little piece is going to go right in here. And now we almost got her licked. 346 feet. Okay, so done figuring that part out. Let's trash that. Okay, so now I'm going to focus on this smaller little triangle right here to find the distance EL. And then we will have all the information we need to answer all the questions about life, the universe, and everything. Okay, so to do that, I am going to again go back to tangent. So tangent of 18 equals the opposite side, which is what we're trying to find, EL, divided by the adjacent side, 41,346. So this time, hopefully you guessed it correctly, I am going to take 41,346 and multiply it by the tangent of 18 degrees. And that works out to be 13,434. 13,434 feet. Okay. All right. So that is just that little tiny piece right there between E and L. 13,434 feet. Okay. All right, so once again, done with these calculations, so let's trash them. All right, so now we can answer the questions that we're being asked. First of all, how high is the plane above the top of the mountain? So we know this distance TL. And then, whoops, if we go TL minus EL, that will give us TE, which is what we're trying to find. So TL was 15,049 minus 13,434, which equals, I do not know what my calculator does, 15,049 minus 13,434. So the plane passes 1,615 feet above the mountain. So I suppose that's safe enough. And what we just found there was TE. Okay, then the other question is, what is the height of the mountain? So that would be easy. That is 20,000 feet, this distance right here, plus this distance right here. So that would be 33,434 feet. That's suspicious. I think that's taller than the tallest mountain in the world, so nice job, UW. Okay, so that's the end of that. So I accidentally stopped that video before, so I'm going to just load two of these. Okay. All right. Hope that helps. Hope you guys are staying safe and doing math to keep yourselves fresh. We will play again tomorrow. Okay. Talk to you then. Bye.